Assalamualaikum warahmatullahi wabarakatuh. Okay guys, meet me again. So in this video I will discuss about sampling strategy, and then which is very important for our lives. See more and happy watching. But peace be upon you and Allah mercy and blessings. Before we start each activity, it will be nice if we read Basmalah first. Bismillahirrahmanirrahim. And next, I will introduce myself first. Let's introduce myself. My name is Dwi Adinda Solihah. You can call me or usually call me in Dinda. I'm from Sidoarjo, and now I'm studying in UIN Maulana Malik Ibrahim, Malang, in chemistry in B class. Okay guys, so happy watching and see more. What is about sampling strategy? Okay. The definition from sampling strategy: sampling is collecting a certain volume of an air body to be studied with the smallest possible number, but still able to represent and have all the same characteristics as the air body. The sample to be used in the parameter must be the same as the condition in the field. So, definition from sampling is collecting a certain volume of an air body to be studied, and then with the smallest possible number, but still able to represent and have all the same characteristics as the air body. That the sample to be used in the parameter must be the same as the condition in the field. Next, sampling or strategy sampling is divided into 3 steps, where sampling strategy in 3 steps must be used to be sampling. The first step is representative sampling, and the second is serial transportation of sampling preservation. And the third, chemical analysis of sample chemical and physical parameters. Okay, the first is representative sampling, that we can get a representative from the sampling. And the second is transportation of sample preservation. And the third is chemical and physical parameters to analyze sampling strategy. And the next, preparation from sampling preservation. The bottle that will be used to take sample must be clean and have been rinsed with distilled water first. Then followed by the liquid that will be used to fill the air. Use air distillation because the water has far less minerals. Preparation for sampling preservation, use the bottle, and then use air distillation because the water has far less minerals. And then things that must be considered when sampling is such as a clean sample and does not contain all sample residues. A high concentration of residual sample can change the concentration of the solution to be made. Not grow, malt, and milk which shall be the tools such as pips, pumps, and other. You can see in the picture of pipes. And the next slide is contamination from metal or air soluble sampling equipment must be bought. Iron, brass, bronze, which can be dissolved in air, are acidic or basic. So iron based bronze is can be dissolved in air are acidic or basic. Meanwhile, waste such as rubber and plastic materials can be dissolved in industrial water containing organic solvent or oil and gasoline. And then samples are taken separately from the pips using a bucket, plastic or glass bottle. Open and heavy glass can be added by tying a rope in the well. River water is usually sampled at deep because when it is shallow the water floats. Sample it with a cap bottle that can be opened to the desired depth or using a suction pump. Samples from the water open must be able to be tagged with an open beaker or bottle to be closed, depending on the analysis plan. Slide. Automatic sample is a tool for sequentially taking sample. So, a tool for sequentially taking sample consists of the number one is about suction pips, maximum 5 meters below the tool, and the two is pump or pip, and the three is clock to control sampling frequency. Using clock because used to be control sampling frequency. And the four divider tool until the bottle with the sample mixture. And the five box isothermic delay. And for when the sample is made for a long time. Furthermore, the sample is put close or can and then closed properly to avoid air box. One of the common ways of preserving samples is preservation of sampling by cooling. Then last slide for sampling strategy is interference during sampling. O2 and CO2 gas can be absorbed by the sample, quietly disappear from utazah until tired. So, O2 and CO2 gas can be absorbed by the sample, quietly disappear from utazah until tired. Like liquids, mud deposit can be on the surface. On the surface is about like liquid, and some solutes can be oxidized by dissolved oxygen so that they turn into compounds. For example, about Mn2 plus. Okay, this is all of material about strategy sampling. And the next.
Okay guys, next material is about analyte contamination. Okay, I will explain you about how analyte contamination. And then let's see and happy watching. Okay. What analyte contamination? The definition about contamination is defined as the entry of unwanted compound into the sample during the sample treatment and analysis process. Source of contamination can come from the atmosphere, apparatus, equipment, water, and reagents. So, contamination is defined as the entry of unwanted compound into the sample during the sample treatment and analysis process. Source of contamination can come from atmosphere, apparatus, equipment, water, and reagents. Okay, next, analyte contamination mainly originates from trace element, particulate on the soil surface, and material suspended in the atmosphere. The way to prevent this is to close the sample report during the preparation and analysis process. Analysis can also be a search of contamination to sample to be analyzed through direct contact and air contacts. Example include man-made smoke and dust. Example of another materials that might come into contact with the sample are powders, perfume, operator shoes, and other. Human skin is known to contain metals even in very low concentration. How to repeat this contact is the use of masks, gloves, laboratory tools. So, if you want to contact is you must use of wear masks, gloves, laboratory tools. Example, you want to contact with the sample are powders, perfumes, operator shoes. And then analysis can also be a search of contamination to sample to be analyzed through direct contact and air contacts. Okay, next. Next is about contamination from equipment. The first is glassware. The glass used in an analytical beaker, borosilicate such as Pyrex. Usually, contamination of the sample from the glass is caused by attack of the container by the solution. Pyrex is less resistant to strong acid and base. HSG glass is more resistant to attack by hot solution. Anticipation of avoidance can be done by washing glassware using a 1-1 mixture of sulfuric acid, nitric acid. Okay, glassware. Glassware is used in an analytical beaker. Usually, actually, they use to contamination of the sample from the glass is caused by attack of the container by the solution. Example of glassware is Pyrex. Pyrex is less resistant to strong acid and base. And next, to keep glass contamination to a minimum, equipment can always be stored and immersed in a dilute solution of hydrochloric acid or nitric acid. This is because of those two compounds can clean the surface of the glass from metal. Okay, to keep glass contamination to a minimum, equipment can always be stored and immersed in a dilute solution of hydrochloric and or nitric acid. Okay, next, preparation equipment that has a lower risk of contamination. So, to make a lower risk of contamination, we can preparation equipment. The first is a fused silica, and the two is plastic, and the three is Teflon, and the four is PVC, and the five rubber, and the six filter paper. Okay, you want to contamination, you must prepare about preparation equipment first. Okay, next, contamination from water. Since water is used in a large quantities that requires special attention should be paid to the purity of consumed water. To reduce this can be done water distillation first. So, for contamination from water to drink, to reduce this can be done water distillation first. Special attention should be paid to the purity of consumed water. You must distillation first to make a clean water from drink. Okay, next I will explain you about other material.
Okay, the next material is about reagent contamination. I will explain you about reagent contamination, how to take it, and Let's see. Contamination from reagents can be grouped into first, mineral acid and ammonia, and the second is about inorganic solid, and the third is about organic reagent, and the fourth is about organic solvents. So, contamination from reagent can be four groups. The next is about, and the first is about mineral acid. Most mineral acid contain a certain amount of metal. Extra pure acid contains very low levels of metal. Generally, reagents of this quality are quite expensive. Extra pure acid are quite expensive, more than mineral acid eventually. And the next is about ultra pure. Contains a very low concentration of metal, but the content of some elements varies from product to product. Analytical reagent acids contain metals according to those listed in the tables. And then about ultra trace, acquired distillation result from several acid solutions, nitric acid, sulfuric acid. The next slide is about ammonia. Ammonia solution in water is placed in a glass bottle and will be contaminated by silica, aluminium, calcium, and other elements that might be caused by attack by alkaline solution in glass. Analytical reagents ammonia can contain heavy metal in very low concentration. This can happen because the absorption of the metal by the glass. Inorganic salt of reagents quality are usually pure enough to be used directly without purification, but a bank control solution must be prepared. Lead PP is an important metal. Purification is usually done by crystallization or filtration. It is about organic reagents. Organic reagents. Organic reagent is a chelating agent usually containing a metal that is coordinately bound. These metals are usually derived from solvents or reagents used in the synthesis of ligands. Organic reagents are usually used in such small quantities that contamination is often overlooked, but caution is required, for example, by using reagents as blank. Next slide is about organic solvent. The metal content in it is usually relatively low, which must be watched out for the presence of the organic compounds dissolved in the solvent because it usually interferes with spectrometric determination. That is about loss analyte. In the preparation, metal separation and determination stage, the analyte can be removed from the sample solution by a factor of the first is about absorption, and the second is about volatilization or evaporation, and the last or third is about co-precipitation or settling. Okay, I think enough. If I have faults, I want to say I'm sorry, and then thank you. Wassalamualaikum warahmatullahi wabarakatuh.